Chapter 8.2 Ellipses. Now we're going to try translating. We had our ellipse with center at 0, 0. Now we're going to look at an ellipse with center HK. H will correspond with the X and K with the Y. So we're going to subtract the H from the X and the K from the Y, and everything else is the same. Here we have a standard equation for a vertical ellipse. We still subtract the K from the Y, the H from the X, and everything else is the same. Our focal axis on this one, it was a long horizontal ellipse, and the Y was equal to 0. It was the x-axis. Now Y is equal to K for the axis. Here it's a vertical axis. It was the y-axis with x equal to 0. Now x is equal to h. The foci on our horizontal, the foci will be lying on the x-axis. So we want to add and subtract C from our center. When it's on the y-axis, we want to add and subtract K to the Y value. Same thing with the vertices. This is on the X values, the x-axis. This will be on the y-axis, or the translation, the axis of the ellipse. And the semi-major axis, semi-minor axis, these all stay the same. So here we have a picture of it. Here's our HK. We went from 0, 0, we moved the ellipse up to HK. So on this one we have the axis of the ellipse. It will be at the value of K for Y. For each of these points, K stays the same. K, 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 K. And the X value is the one that's going to shift. We add and subtract A to get the vertices. We add and subtract C to get the foci. When we look at the ellipse that goes up and down, here's our HK. The X value will stay the same, H, 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 H. And the K value, which is the Y value, is the one that we add and subtract to find the foci and the vertices. So let's try it. Find the standard form of the equation for the ellipse whose minor axis has endpoints -1, 4 and 5, 4, and whose major axis has length 8. So let's start off by drawing a picture with our -1, 4 and our 5, 4 for the minor axis. And in this particular equation, the minor axis is along with the x value, so this is incorrect. We'll go with it for here, but you need to know that it is incorrect. I'm sorry, I can't fix it easily from this slide. X minus h over a squared plus y minus k squared over b squared is equal to 1. The center is the midpoint of the minor axis. From -1 to 5 is 6 units. So we count 1, 2, 3. And we get 2, 4 to be our center. 5 minus -1, 6 units divided in half is 3. The semi-major axis is B. The major axis was 8. B, the semi-major axis, is 8 divided by 2 is 4. So now we have our A, we have our B. We're going to put the minor axis with the X, the major axis with the Y. Multiply it out, we get x minus 2 squared over 9 plus y minus 4 squared over 16 equals 1. The correct standard version of this equation would be having the y value first because it's the larger. Try this. Find the equation of an ellipse whose major axis endpoints are -2, 1, and -7, and whose foci are -2, 1, and -2, 5. First thing you want to do, draw a picture. Then find the midpoint and go from there. Pause the video while you work it out. Locating key points of an ellipse. We want to find the center, vertices, and foci of this ellipse. If we're given the equation, how do we find the parts of it? In this case, we're going to put it in standard form first. Because the y is over the larger number, we're going to put it first. So we get y minus 1 squared over 9 plus x minus 1 squared over 4 is equal to 1. So the center would be at -1, 1, and it's -1 with the x. This would be 1 with the y. The semi-major axis, a squared is 9, so the square root of that is 3. The semi-major axis is 3. So the vertices, it's on the going up and down, so the x will stay the same at -1. And the y, we want to add and subtract 1 plus 3 and 1 minus 3. So we get -1, 4, and -1, -2. So we have our a and our b. A is 3, b is 2, and c will be the square root of a squared minus b squared. 9 minus 4 is equal to square root of 5. And the foci, the h stays the same for the x value because it's a vertical ellipse. And we add and subtract c to the y value. So it will be -1 and 1 plus square root of 5 and -1, 1 minus square root of 5. And if you put it into your calculator, you'll get approximately these numbers. Try this. Find the center, vertices, and foci of the following ellipse. Just a quick look at orbits, elliptical orbits. Here we have the sun as a focus and an object orbiting the sun. Here's the center and the semi-major axis. And just an introduction to eccentricity of an ellipse. The eccentricity is the ratio of the length to the width of an ellipse. How round is it? How stretched out is it? We'll be looking at eccentricity in some later chapters. This is just an introduction to it. And now just for fun. One day, a farmer called up an engineer, a physicist, and a mathematician and asked them to fence off the largest possible area with the least amount of fence. The engineer made a fence in a circle and proclaimed that he had made the most efficient design. The physicist made a long straight line and proclaimed, "We can assume the length is infinite," and pointed out that fencing off half the earth was certainly a more efficient way to do it. The mathematician just laughed at them. He built a tiny fence around himself and said, "I declare myself to be on the outside." See you in class.